We're going to look at a quick way of finding the nth term of quadratic sequences. Now, there's a lot of different methods out there for finding the nth term of quadratic sequences, but I think this one I'm going to show you is probably the easiest one that there is. So we're going to jump into this example. First of all, before we do that, it says for a quadratic sequence, the nth term is an squared plus bn plus c. So basically what we want to do is find out the value of a, the value of b, and the value of c, and then we have done it. So it has for it to be a quadratic sequence, there has to be an n squared term. So that means a has to have some sort of value. Okay, but the b term might not exist, and the c term may not exist. Right, we're going to jump into this example. It says, find the rule for the nth term of the sequence, which is 5, 10, 17, 26, and 37. Okay, so if we just write that out again, what do we have? We had 5, 10, 17, 26, and 37. We'll just do our common differences. First difference is 5. The next difference is 7. The next difference is going to be 9. And the next difference is going to be 11. Okay, so we haven't got a first difference wasn't consistent, so that means it's not a linear sequence, so it must be a quadratic sequence. We go on, and our second difference is 2. Now your a is equal to 2 divided by 2, which is equal to 1. So what we know so far is we've got 1n squared and then plus bn plus c, and we have to find that. Okay, now this is what I'm going to do different, which is different than what a lot of other people do. So what I'm going to do is go back. I'll change the color of this pen. I'm going to go back, and if that had been a 2, it's going to be 2 all the way along. So I take 2 away from the 5, you get 3. So if I go back 3, I get 2. Now what we have just found is actually our c term. So we now know our c term is 2. So our nth term so far, we know it is now equal to 1n squared, so it's just n squared, plus bn plus 2. Okay, so all we're left to do is to find this b term. Now what we can do is use any of our original values. So here, this 5 is my nth term, my value of my nth term when n is equal to 1. This 10 is my value of my nth term when n is equal to 2. This 17 is the value of my nth term when n is equal to 3, and so on. So the easiest one to use is the easiest number, which is 1. So we're going to be looking at this 5. So this was, remember, 5 is the result when you put n equals 1 into this sequence. So basically I'm just going to say 5 is equal to 1 squared plus b times 1 plus 2. And that's a bit of a mess, so we'll tidy it up. 1 squared is 1. B times 1 is just b plus 2. And then they'll tidy up again. That's 5 is equal to 3 plus b. And a wee bit of working out, you're going to get your b is equal to 2. So overall, your nth term is n squared plus 2n plus 2. And that's it done. Okay, let's just check and see if that works. Let's pick a random value. I'm going to have to do this on my calculator. I'm going to pick this one. So that was my first. That was my first term, second term, third term, fourth term, fifth term. So I use my fifth term. So when I put n equals 5 into it, I should get 37 if this has been worked out correctly. So I'm just doing this here, squeezing this on. You wouldn't have to do this normally. So n was 5 squared plus 2 times 5 plus 2 would be 25 plus 10 plus 2, which would be 37, which is what I had hoped it would be. Okay, so that, in my opinion, is the nicest way of doing nth term of a quadratic sequence. So we'll look at a couple more examples on that, just to see how quick and easy it is to do. Okay, next example says, find the rule for the nth term and then the 20th term of the sequence of the triangular numbers, which are 1, 3, 6, 10, and 15. So again, common difference is 2, then 3, then 4, then 5, and that goes 1, 1, and 1. Okay, so your first term A is always going to be your common difference divided by 2. So a is just 1 divided by 2, so a is equal to half. So what I have got so far is my nth term is equal to a half n squared plus bn plus c. So I've still got to find my b, I've still got to find my c. So I'll change the color of the pen here, and I'm going to go back on myself, and I'm going to go back 1. So, and if I take 1 away from the 2, that gives me 1. If I go back 1 from here, that gives me a 0. So that tells me my C term is 0. So I'm going to write it in just for the sake of it. What I know so far, it's a half n squared plus bn plus 0. Now, the next time I'm writing this line, I will not be writing the 0. Right, again, just like the last example, this 1 represents the value you get when you put n equals 1 into this equation. So that means 1 is equal to a half upon 1 squared plus b times 1, and I'll just put the 0 in again, and next time it'll be gone. And then we can just tidy this up and find out what b is. So 1 is equal to a half times 1 squared is just a half, plus b times 1 is just 1b. And then take that 1 away, or a half away from both sides, you're going to have 1 minus a half is equal to b, which means we better working out b is equal to a half. So your nth term here is equal to a half n squared plus a half n. And that's the nth squared that I'm going to use to find my 20th term. So to find my 20th term, so say 20th term is equal to, and it's going to be a half times 20 squared plus a half times 20, and whatever that works out to be, let's see, that's going to be a half times 20 squared is going to be 400, and a half times 20 is, we'll just do that one out, it's going to be 10. A half times 400 is 200, plus 10 is going to be 210. Okay, the last question for us. It says find the rule for the nth term and then the tenth, hence find the 10th term of the sequence, minus 1, 5, 15, 29, and 47. So again, first difference is 6, then it goes up to 10, then it goes up to 14, then it goes up to 18. So my second difference, which is common, is 4, and my a, remember, is your second difference divided by 2, so a works out to be 2. So what we have got so far, my nth term is 2n squared plus bn plus c, and of course we're just left to find what b and c are. So let's just go back on ourselves then. I'll change the color of the pen. Going back 4, which 6 minus 4 gives me 2. Go back 2 from, go back 2 from minus 1. I'm going to get minus 3, and that, remember, is my value of my c. So put that in over here. What we know then so far, my nth term is 2n squared plus bn minus 3. And then we can, pardon me, we can then just check out this number, which is minus 1. So minus 1 is a value when you put n is equal to 1 into that sequence. So that's 2 times 1 squared plus b times 1 minus 3. So minus 1 is equal to 2 plus b minus 3. So minus 1 is equal to 2 minus 3 would give you minus 1 plus b, which means your b works out to be 0, which is a bit weird, but that happens, it's fine. So your nth term is equal to 2n squared minus 3. Now all we're left to do is find the 10th term. So we'll just say, so we're using 2n squared minus 3, so we'll just say when n is equal to 10, 2 times 10 squared then minus 3 is going to be 200 minus 3, which is going to be 197. So your answer, 10th term, is equal to 197. And that is it done.